Okay, sorry for a little bit of a late start. I was trying to add something last minute. Hopefully everybody can hear me today. I believe I fixed my mic. I've got a couple things to go through, more than just the lesson today. Some good news, maybe some better news. We'll see. I'm going to jump into that here real quick now. The first thing is I have this video here. I don't want to play a video because I'm remoting my screen to all the screens in the classroom right now, as well as you're watching me live on YouTube. So right now, I don't want to do that just because the video is not going to carry very well. But I've left this link here. I want you to watch it. It's a TikTok. I think he's definitely 60 seconds, but you don't have to watch the whole thing. You can get the gist of it after the first 45 seconds or so. This guy's a programmer who works with Microsoft, and he just talks about who is considered an expert or a master in a given language. And it's just a very interesting take on that language, and it plays really well into these last three lessons that I'm going to do, because I spent a lot of my time over the last few years teaching myself the basics of Java and moving into arrays and array lists, and everything after that is still new for me from a specific point of view. So I instruct this stuff exactly the same way. I have the lessons that I've put together and I've used over time, but there's still times where I'm doing something with arrays and I mess it up and I can't figure out what I did wrong. Okay, so I am not, and I said this at the beginning of this course, I'm not going to pretend that I'm an expert or a master when it comes to Java. Every time I discover something new in Java and I do something right, I realize how much I don't know about Java. So it is a very big language. It's immense. There's a lot of stuff going on. So as we go through this stuff, we'll be patient and we'll go through that. Now that brings me to the good news. And if we want to talk about the good news specifically, is I am not going to expect more from you than what I could provide. So going through these last assignments, please make an attempt on them. That's the big thing that I want you to do. I want to see an attempt at an array. I want to see you attempt to remove an item from an array. If you've got errors all over the place, I'm not going to mark these ones as hard as I do the previous lessons, because these ones are a little bit more confusing, a little bit harder to get through, and I'm not even the best at them as we go through. So for these assignments, please and thank you, spend 20 minutes, half an hour to an hour. If you can't get it, submit it to me where it is. I will do my best to see if I can find where the error was, and don't worry as much about the marks per se. Take an attempt. That's what I'm expecting you to do for these three, as well as 1, 2, 3, 4 in module 2. I can't add the binary anymore. Whatever module this is, okay? These 4 assignments in here, make an attempt at them. Now, this assignment at the very bottom is one I just added yesterday. I did one of these last year for the staff. Mrs. Donnelly came to me and said she wanted a reverse draw for the staff, and rather than do it the old-fashioned way with a hat, I used an array, put all the teachers' names in the array, and then I had my program take one person away every 20 seconds so that by the time the teachers were done for the day, at the end of, I think it was at Christmas time, one person was left in the array, and that one person was the winner of whatever prizes we had. So I had fun with it, trying to make it all work and putting it all together. So I threw it in there because I wanted all of you to try it as well. So that one is new. Like I said, it's still just make an attempt. Do your best that you can come up with for these last few. I'm not going to be uber critical of these last 2 modules worth of assignments. That's also why I don't put a test in there, just because it's much more difficult than everything else we've covered previously. Okay? All right, moving on, lesson 14, arrays. This video here you can watch, like I said before. I'm not going to stream another YouTube video. I actually think I would get in trouble if I did that copyright-wise. but this is a very good example of how an array works, okay? And I have the same example down here. An array is like a bank of lockers, and you can store different items in each locker. The locker has a designation so that it has a specific number that would indicate where it is, and inside every locker of your array you have to have the same type of thing. So you have to have the same data type in the entire array. Okay, that's the only difference than the lockers out in the hallway right now. Okay, that's the idea behind an array. This video is very short, maybe 2 minutes. It does kind of the same thing, but it just kind of explains what an array is a little bit better. Okay, to declare an array, specify the type of elements that are going to be in the array. So you're going to specify the data types, and then you're going to use two braces to show that it's an array of that type. Okay, and you can see down here we have an array that's been created, and it's an int, so that's the data type. The braces explain that it's an array of integers, and it's called high score. So that's the designation of that array, and the value of the array is null because we're still just declaring it. We're not actually creating that array. We're kind of just creating a spot to save that array. All right? And we're identifying what we're going to put in it. And I think I covered that in here. The declarations do not create the array. Arrays are objects in Java, so any variable that declares an array holds a reference to the object. If the array hasn't been created yet and you print the values, it'll print null. So if we printed this statement right here, it's going to print null, okay? Because the value of these two things is null, therefore there's nothing for it to print. Okay, I believe I have that. No, that's for the next one. Okay, next page. To create an array, use the new keyword followed by space, and then type, and then the type, and then in square braces, the size of the array. So if we're going to create an array called high scores equals new int 5, we're saying we're creating an array called high scores, and it's going to fit 5 items in it. Okay, and we declare what those items are here as an integer, so we're putting 5 integers into the array high scores. Now it doesn't necessarily mean, I'm going to leave that for now. Okay, array elements are initialized to 0 if they are a numeric type. So if you have an int, double, float, long, byte, whatever it is, if it's a numeric data type, when they are first introduced, the value of every spot in that array is going to be 0. And you can see that here. So we have this array called high scores. It's an int. Everything in that array is going to be an int. It initializes as a 0. So everything in every single spot is a 0. Okay, if it's a Boolean, then or a null type, then like a string, then it'll return null. So we have names here, which is a string. Those ones are going to return an initial value of null. Okay? It's also important to remember that we're working with an index again here. So just like when we were, using slices and we were cutting up and concatenating different strings, the same thing is going to occur here. The first spot in the array starts at index point 0. Okay? So the 0 starts it. So you always have to remember that the first spot's 0, not 1. Okay, this one I have an example of here. So to put a value into an array, you give the name of the array, the index number in brackets, and then an equals, and finally the value, semicolon. So we can see the example here, high scores, 0 equals 99. The first item in that array is index 0. Okay, so this is an example. I'm going to get to that right away. I have one of my own. You can also initialize the values in the array when you first create it. So up here, we're creating the array, and we're not putting anything in it. Okay, we're just saying, hey, there's going to be 5 spots in this array, but there's nothing in it yet. And then we add all of these items here to the array. If we want to, we can initialize the array with value in it. So we can say our array is going to be an int. The braces indicate that it's an array. The name of the array is high scores, and here are the values we're going to insert. Okay? If you initialize the value when you create the array, it will automatically set the length of the array to be the number of values you put into it. Okay, so you don't have to indicate, hey, this one's going to have 5, and then give the 5 items that are going in there. It will just assume if you're giving me 5 items, this array holds 5 things. Okay, and I have that example right here. Okay, so this is the same one right here that we had. I actually can't remember what I print in here. Right, this is what one student had this question before in terms of printing out the arrays in the whole. Okay, when you try and print them out completely, you get this. There's a background behind this, and I was reading it yesterday, but I didn't spend enough time on it. If you look at these last 2 outputs, okay, we're printing out a specific index spot. So when we print out the array itself, we're not going to get any valuable information. But if we print out a specific index point, so if we say system.out.print, we want to print from the array high scores, and we want to print position 0. Okay, then it's going to print to us whatever's first, which is 99. Same thing here. We want to print position 0. That's Jamal. Okay, I'm not sure what happens if we do this. Okay, that's not going to work. Okay, anyway, that's how you would initialize it. That's how you would create it, and that's how you would put value into it. And remember, you don't have to add each item individually like this. If you know what the items are as you're working, you can put them in immediately. Okay. Array length. Arrays know their length and how many, which is just how many elements they can store. It's a public read-only field, so you can use dot notation to access it. So you can just say the name of your array dot length. Okay, dot notation is using variable name followed by a dot, and the field property name or a method name. Okay, so this will tell you the length of the array. The length of the field is not a method, unlike the one we used with string where it was length with the open and close parentheses. So the one we used with arrays, you don't have to put the parentheses in there because it's a field, not a method. So you just have to say dot length. When we use this system.out.print line high scores dot length, it's going to print out the total length of the values in the array, and I believe that's this one. Okay, so I created these arrays with the values in them when I initialized them, and then I printed out position 0 in both, and then I asked for the length. The length of high scores is 5. Now if I add more into this, and then run that again, changes our value to 8. Okay, so we don't need this one in here, which we have used with strings in the past, because it's not a method. All right. Okay, looping with the for each loop. You'll often loop through all the elements of an array to get the average or to get each one to display. You'll typically do this with a for each loop. A for each loop can only be used on a collection of items, so it's going to go through all of them. If you're using a for each loop, that means you want to go through every single one of them, not just a set amount. Okay. Another name for a for each loop is an enhanced loop. So I have an example of this one right here. And we set it up as a get average method, and it's expecting a value to come in as an array here. And then we have our for each loop here. For int value, values. What it's saying is the for each loop is shown on line 6. It says to loop through the array called values, and each time through the loop, it sets the variable val to the next item in the array. So it's saying int val is going to loop through the array passed into values. Values is passed in up here. So as this loop iterates, it's going to move from the beginning, from the position 0 in the index to position 1 to position 2 to position 3 to whatever the last position in the value is. Okay, and in this case, after it's done that, it goes through each one. It's going to add the total plus value. Now, our total starts out as 0. So as our for loop loops through the array, it adds total to the value. So the first time this runs, there's nothing actually happening here because this is a method. When we get to our main method here, we create our array that we're going to use, and then we call our getAverage method. And we say we want to call that method, and we're going to put the value of arrays in there. I have such bad names for things sometimes, it drives me crazy. The value that we're going to, the numbers that we're going to pass into our method are in the array called values. Okay, our array called values is here, 2, 6, 7, 12, and 5. We pass that in here. So now, when we loop our item, because we've called it, so now this method is being called and it's going to be used, it's going to loop through from the first position to the last position. Each time it loops, it's going to add the total of whatever the variable total is with whatever the value of val is each time. Okay, so the first time we go through, total is equal to 0, value is equal to whatever's in the 0 position of the array, which is 2. So the first time we iterate this loop, we've created a variable called total with a value of 2. Then we loop it again. It's now 6. Val is 6. Total is 2. So we're now at 8. We loop it again. 8 plus 7 is 15. We loop it again. 15 plus 12 is 27. We loop it again. 27 plus 5 is 32, I hope, or I'm going to look stupid. Okay, so the value of total is now 32 that we've worked our way all the way through. We still haven't printed it or gone through anything. All we've done is return the value of 32 to total. Now the loop terminates because we've gone through the entire length of the array. So the loop terminates and it returns. We go on to the next line, line 10, and we're going to divide total by the length of values. The length of values is 5. Remember, it's not using an index point, so it gives us the actual number of items in the array. It divides our total of 32 by 5, and it gets us an average. Okay, and I believe I have that one right here. Okay, exactly the same code that was in the lesson. So when I run that, it gets us 6.4. Now if I change this to be something different, it's going to change our average. Okay, and I just put 5s in there so we know it's working, because I don't want to do the math right now. Okay, that's how that one would work. Only use a for each loop when you want to loop through the entire thing. I already talked about that. The code above wasn't object-oriented. You may have noticed that it was declared as static, which means that it's a class method, not an object method. It is a class method since it doesn't operate on any object fields. Okay, and we're going to get more into using objects in a second. Using a for loop to loop through an array. You can also use a for loop to loop through all the elements of an array. Just start the index at 0 and loop while the index is less than the length of the array. Okay, so if we look at this example here, I don't have this one in a Eclipse example right now, but I'm going to go through it quick and then I'll move on to the next one that I do have. So we set up our array called values, and then we have a constructor that's called array worker, and it's going to expect an array being inserted into it, and whatever gets passed into this constructor is going to become the exact same value as values. I really hate the way I've named these. Then we have a second method, or we have the first method here that's called mult_all, and we're expecting an int amount coming into that. So then here's our loop. We have for int I equals 0, so our start point is going to be, if int I equals 0, that's the start point. It will continue until I is less than the values dot length. Okay, so it's going to continue until it equals the length of the array, and it's going to go up by 1 each time. So we're going to add 1 to I each time the value loops. Okay? As it loops through, it continues to add 1, so we use this down here as our main method, and then we create our array that we're going to pass into our method. We create an object of that array, and then we call mult all, and then we call print values. So we insert this array into mult all, so actually into here, and it creates values with the value. So then we can run this for loop. It loops all the way through it, and then it prints it out. Okay, I was looking for this one. I did have it set up somewhere, but now I can't find it. I have this one, which is basically the same thing, just not object-oriented. I have the array here with the values put into it. I create an int I, and then I say for int I, start when the value of I is 0, go until it's less than or equal to 5, and go up 1 per iteration. So when I print this out, it loops through and grabs each of the first 5 parts of that array. And you can see them up here. Okay, 96.5, 98.7, 99.5, 3, and then it stops once it's equal to 5. So it's only going to give us 5 entries from that loop. I am running out of time. The bell's going to go very quickly. Okay, looping from front to back. This is the one that can become very, very confusing. If we want to create a method called index last smaller that is going to provide you the index point of the number that's smaller than your target, that is this code that I've created here. And I have this example in here. I'm going to go through that one just hopefully fast enough that the bell doesn't go here. But so I can create my constructor. I'm going to pass my array into this section here so that the values array has data in it. And then I create my get index last smaller here. I have my loop start when the int index is equal to the values.length minus 1. So values.length is the minus 1 is the last spot in that array. So you can see the array I'm going to pass in is down here. The last spot is 46. So it's going to start checking 46, and it's going to go until it's equal to or greater than the 0 position on the index, and it's going to minus 1 each time. Okay? And then if values index is less than target, we'll return the index position, because that's what we're looking for. We're looking for the number that is lower than the target we pass in. All right? And you can see down here when I call the method, the target number is here. Okay? And that's what's being passed into this method right here, which is the number 50. It's expecting an integer, and the integer is called target. Okay, so if the value in the array is less than the target number, return the index point of that number. If it goes all the way through the entire list and no numbers are lower than the target number, it returns minus 1. Okay, and then here's our print function here for us to be able to print out our answers. Okay, so the first one I have, and if I block out the rest of these, I'm just going to call this one. So what this entire program is doing is searching through the array to find a number lower than the target number we provided. So the user provides, or the programmer provides, the target number, and I want it to search from the back of the array to the front, looking for a number that's smaller than 50. Okay? This one is going to return 4, because the first number in the array from the back is lower than the target number. So position 0, 1, 2, 3, 4 is lower than 50, so it's going to return 4. I hope, or I'm going to look dumb. Okay, so it returns 4. And as I go through and add the rest of these, it's going to now return the index position of any number lower than 30. Well, 4 is not lower than 30, so it's going to keep checking. It finds a number lower than 30, and it returns this index position. So now it's going to return 4 and then 3. And so on and so on and so on. And you can see as the target number changes, it takes one further number into the array for it to find a number smaller than that, smaller than or equal to. Okay, so when I return it, it's looked through and found that this very last one, minus 30, it took all 5 positions for it to find a number lower than or equal to my target. Okay, and then it gives me a minus 1 because it didn't find any of them. Okay, that's how you would move from the back to the front, which is this line right here, and how you could create a method that's going to scan for something specific that you've provided to that the user's provided or the programmer has just provided as well. Okay, if you look at this as an array with 10,000 numbers in it, it would be easier for you to create a method that can check each number rather than you having to check it yourself. Okay, that ends lesson 14. Bill's going to go right away here. So like I said, do your best with those assignments. Take a stab at them. Let me know if you have questions. Somebody asked if we could go over the final assignment again. I will do that probably tomorrow when the student who's asking is here, because I don't want to bore everybody with that. Okay, let me know if you have questions, email, messages through Moodle.